Hey guys, so here's part 2 of the test review video. So number 11, the original price is $2.60. If the price next year were 5% more than this year's price, what would that price be? Okay, so we want to see the original, what we started off with. We have 5% over 100, or 5 over 100, and we want to see how much that changes $2.60. So we'll see x equals here 13 cents. So the price would increase by 13 cents. So the new price would be $2.60 plus 13 cents, which means the new price would be $2.76. Now, if the price dropped 5% the year after that, we need to see how much that would drop the price. So we're going to put 5 over 100, x over 276, and we're going to solve for x here. Okay, x equals 138 thousandths, but if we round this properly, it will round to 14 cents. Okay, and if we take $2.76 and we subtract 14 cents from it, we can see that the price now goes to $2.62, which would mean that it did not go back to $2.60. Okay, so thus we've proved that the price should not return to $2.60. All right, number 12. A computer software retailer uses a markup rate of 40%. Find the selling price of a computer game that cost the retailer $25. Okay, so we're going to take 40 over 100, and we're going to set this equal to x over 25. Okay, because 25 is the whole price of the computer game at the moment, and we want to see what happens when we increase the price by 40%, or how much we would increase it if we increased it by 40%. So we find that x equals 10, which means that the markup was $10. So 25 was the original price of the game. And after we increase the price $10, the new selling price will be $35. Okay, number 13. Stephanie reduced the size of a rectangle to a width of 5.5 inches. What is the new height if it was originally 20 7/10 inches tall and 16.5 inches wide? Okay, so all the units seem like they're the same. They all seem like they're inches, but we have to be careful here. If we say that the original rectangle was 20 7/10 inches tall over 16.5 inches wide, we could set this equal to, well, we don't know how tall the new rectangle was, the reduced size, and we do know how wide it was. So here we go. We set up a proportion where all of our units line up, and that's exactly what we're looking for here. Cross multiply and divide, and we'll see that x equals 6.9 inches tall. All right, number 4. A square frame was increased from 64 inches squared to 100 inches squared. By what percent were the side lengths increased? Okay, now here we're talking about the side lengths of a square frame, or two square frames. Let's remember, in order to find the length of one side, if you're given the area of a square, we have to take the square root of one of the sides, of the area, and we will find the length of one of the sides. So the length of one side of the 64 square inch square frame is 8 inches. Okay, similarly, if we take the square root of 100, we'll find that the length of one of those sides is 10 inches. So now we want to know what the percent increase was. Well, that's simple. That's just 10 minus 8 all over 8 times 100. And this is going a 25% increase. The real trick about this problem, guys, was remembering if you're given the area of a square and you want to know the length of one of its sides, you have to take the square root of that, the area. All right, number 5. If the price of a softball glove decreased from $60 to $36, what was the percent of decrease? So most of us got this one right. 60 minus 36 all over 60 times 100 equals a 40% decrease. Should write decrease in. Okay, number 16. A DVD movie originally cost $24.99. Its current price is $19.99. So we will do, what is the percent decrease? So it's the same thing, $24.99 minus $19.99 all over $24.99. And then we multiply this all by 100. And then we would get, after rounding, that this is about 20%. Okay, number 17. Kate had $2,251.35 in her bank account. Currently, she has $1,975.86 in her account. Find the percent decrease. So, just like the last couple of problems, we're going to set up the percent decrease formula. Multiply this by 100, and we will get the percent decrease. Okay, and after rounding, you would get that this is a 12 and 2400% decrease. Okay, number 18. In 1986, the average price of a gallon of gas was 93 cents. In 2007, the average price of a gallon of gasoline was $2.77. Find the percent of change. Okay, so this is just 277 minus 93 all over the original price, and the original price was 93 cents. We multiply this by 100. Okay, and after rounding, we would get this as 197 and 8500%. Now we have to decide, was it an increase or a decrease, and the price went up, so it is an increase in price. Okay, number 19, this is one we did in class together. A store is going out of business. It offers a 50% discount on its items. The next week, the store offers an additional 50% off. Is the store giving away items for free? Prove your answer. What percent of the original price are you actually paying for an item? Remember, when we deal with questions like this, it's often best to propose the price of an item, and we're going to propose the price of this item to be $100. Whenever you're dealing with percents and you need to make up a price to figure things out, go with 100. It makes life easier in the end. Okay, so a 50% discount on a $100 item would be, if you wanted to set up the proportion, you could do it like this, and we'll find out that the discount is $50. So if we discount it $50, that means you're only paying $50 after the first discount. Okay, well, the next week we offer an additional 50% off, so we have to see what that discount would be. And here we're going to find that x equals 25. So we subtract 25 from 50, and we find out that the cost of the item is $25. And no, we're not giving it away for free. Now we need to find what percent the original price you're actually paying for this item. Okay, so we're going to take 100. We're going to take 100 and subtract 25 from it and find out we received $75 off. Now we want to see what the percent decrease is from that. So we would do 100 minus 75 over 100 times 100. And you would get 25%, and that's the actual percentage of the item. That's the actual percentage of the price you are paying for the item. Okay, and it all works out that way because we started off with a $100 amount. All right, number 20. Much like number 19, on Monday you withdraw 20% of the money in your bank account, and on Tuesday you withdraw an additional 20%. What percent of the original amount is left in your bank account? And like I said on the last problem, if you ever have to invent a number to help you out with a percentage problem, invent 100. So we're going to say on Monday we started out with $100. Now, after we withdrew 20% of that, we're going to find out we withdrew $20. So that means beginning on Tuesday, there's only $80 in the bank account. But then on Tuesday, we withdraw another 20%. So we could set up the same proportion. And in this case, we're going to find out that $16 was withdrawn. Okay, so we're going to see that a total of $64 is left in the bank account. Now, what percent of the original amount is left? Okay, so what percent of the original amount is left in your bank account? We could figure this out a couple of ways. We could say that we had 64 over 100 equals x over 100. We'll find out that x equals 64%. That's probably the easiest way to figure it out. Okay, take the time to review these videos. Like I said in class the other day, make sure that you're on Google searching for similar problems, because I will find them and I will use them. Don't forget, Monday we're going to go over these together in groups so we can find out our specific mistakes that we made on the test. And then on Tuesday we are taking a retest. Okay, thank you very much. Have a good rest of your weekend.